Financial Algebra. We're going to be covering lesson 9.9 on optimal outcomes. And so first I'm going to start with some vocabulary before we jump in. And we are going to be using Desmos. So I'm going to dim my phone so that Desmos is actually visible on it. All right, so first, optimal outcomes in the business world. This is usually both, where you get the maximum profit with the least expense or minimum expense. Constraints are limits to the resources your business requires. So it might be a constraint on the amount of wood you need, or the amount of steel you need, or the amount of napkin. These are things that have to be considered for your business to operate. So number one says determine whether each of these following points falls within the profit feasible region defined by the following. So I have 3. I have x has to be greater than 0. I have y has to be greater than 0. And this third one, if I plug them in, 7 times x plus 3 times y is less than or equal to 45. Now looking at all of these, x is greater than or equal to 0. And y is also greater than or equal to 0. All of these meet this requirement. None of these are negative, right? That would have been the only case you can't have negative. This one includes a 0, but it does say it can be equal to. So the only one that I need to check is I need to check to see if they meet this one. So I'm going to start with part A. So I'm going to be plugging in 2. So using a calculator is 7 times 2 plus 3 times 2. Is that less than or equal to 45? Well, this gives me 14 plus 6. And yes, that is less than or equal to 45. So A would be yes. Okay? I'm plug in points into this equation. So now B, I'm plugging in 5, so is 7 times x, right? 7x, and this is my x value, plus 3 times 1. Is this less than or equal to 45? Well, I get 35 plus 3, that is 38, and yes, 38 is less than or equal to 45. All right, now let's try C. For C, I have 6 and 4. So is 7 times 6 plus 3 times 4 less than or equal to 45? So that gives me 42 plus 12. That is not going to be less than or equal to 45. And so C is no. And then we're just going to continue going through our points. So part D, I'm plugging in 4 and 8. So is 7 times 4 plus 3 times 8 less than or equal to 45? Well, 28 plus 24, that would be 52. That is not less than 45. So D is also no. Last but not least, E, so I'm plugging in 0, 15. So 7 times 0 plus 3 times 15. This gives me 0 plus 45, and 45 is less than or equal to 45. So E is yes. So moving on. So here is the vertices. Now I want to go over something. When they say vertices, so here's my x-axis, here's y. So let's say I have the following equations. And I will use arrows so we know that these lines continue. So when they talk about vertices of a feasible region, they're referring to the point at which our lines intersect. And so these points are called our vertices of feasible region. And so they're wanting us to find what is the maximum profit. And so here is, remember, capital P equals profit. Lowercase p is price. So we're wanting to check these points and find our maximum profit. So for part A, I'm going to test 0, 300, 0, 0, and 1200, 0. And I'm plugging it into this equation here to find our maximum profit. So for the first one, take your calculator. You would be multiplying 120 times 0 plus 170 times 300. And so that's exactly what we're going to do. I don't need Desmos for this. So 120 times 0 plus 170 times 300. And I get 51,000. So for this one, I get a profit, that's what P, of $51,000. Next, the 0.00. Hopefully you can tell just by looking at that if I multiply by 0 for both of these, I just get 0. It's definitely not any profit, right? So last one, I'm plugging in 1200. So 120 times 1200 plus 170 times 0. So 120 times 1200. I don't need to enter this because that's just 0. So this gives me 144,000. So which point provided me with the greatest amount of profit? Well, the 144,000 is the greatest, and that was given to me by this point here. So what is the, it would be this equation at this point at $144,000. So this is the vertices that were provide me with the greatest profit. So they'd like us to do the same for part B. So for part B, they gave me 4 points to check: 2070, 6080, 8090, and 4010. Again, we're using that same equation, so 120 times x plus 170 times y. So this will probably be the last time I write it down. 120 times 20 plus 170 times 70. And I get a profit of 14,300. So let's plug in the other ones. I'm just going to edit what I typed. So now I'm entering 60 for x. My bad. Plus 170 times 80. And this profit here is 20,800. So same equation, but now I'm plugging in 80 for x, so I'm just changing the x. And you can do this on Desmos as well. And 90 for y. This gives me a profit of 24,900. And last one, I'm plugging in 40 for x and 10 for y. This bottom one gave me a profit of 6,500. So we're looking for maximum profit, which would be this one. So a maximum profit of 24,900. That's our max profit using this middle point, 8090. So pretty simple in the aspect that you are plugging values in. Number 3, we're doing the same thing, except we're looking for minimum cost. So we want to pay really close attention to where it says maximum profit. So maximum profit means I'm looking for the largest profit. In number 3, I'm looking for minimum cost. So I'm looking for the lowest cost using this equation, and they'd like us to check our points. So pay careful attention to your homework if it's asking for maximum or if it's asking for minimum. So for part A, I'm plugging in 4 points: 2, 9, 10, 20, 15, 13, and 8, 2, and I'm plugging them into this equation, 57 times your x plus 88 times y. And so we're just going to take turns substituting each of these points in for x and y. So 57 times 2 plus 88 times 9, and I get a cost of 906. So now let's try the next one. So 57 times 10 plus 88 times 20. This gives me a cost of 2,330. Next one, 57 times 15 plus 88 times 13. This gives me a cost of $19.99. Remember, these are all, dollars. And last, 57 times 8 plus 88 times 2. And this gives me a cost of $6.32. So because I'm looking for my minimum, here is the minimum cost for part A. So using the 8 of x and 2 of y, I get a minimum cost of $632. So I'm going to repeat that for B. So I'm now trying the following points: 50, 80, 70, 120, 90, 180, and 120, 90. Now I'm going to guess it's the first one because it overall has the smaller numbers, but I could be wrong. So same equation, right? C equals 57x plus 88y. So 57 times 50 plus 88 times 80 gives me this first cost of $9,890. Next point, I'm plugging in 57 times 70 plus 88 times 120, and I get a cost of $14,550. And so now this next one, 57 times 90 plus 88 times 180. Ooh, the cost here is a lot greater, $20,970. And then the last one, 57 times 120 plus 88 times 90. I get a cost of $14,760. So the minimum cost here would be a cost of $98.90 using the 0.5080. All right, so the following says to determine both the maximum and minimum values of the function as well as the point at which they occur. So when I see profit, I'm looking for my maximum. When I see C, I'm looking for my minimum. Sorry, there's an extra line in the word minimum. Okay, right? That makes sense, right? I want the most profit, and I want the smallest expense or smallest cost. Sorry, I'm going to have a bite of my breakfast. So here we go. I'm going to plug each of these points into this equation. So 81 times 6 plus 57 times 3. And this one gives me 657. Next one, 81 times 10 plus 57 times 10. This gives me a profit of 1380. Next one, 81 times 15 plus 57 times 7. And that gives me a profit of 1614. So I have a maximum profit of 1614 or 1,614 at the point 15.7. And that's how I would state that. So now we're going to repeat that though for the cost. So $98.15 times x, which is 0, plus 63.5 times my y value. This gives me a cost of $50,800. Next, I have 98.15 times 40 plus 63 50 times 1,000. This gives me a cost of 67,426. So already, this first one is the lesser, right? This is my minimum so far. Now let's move on to the next point, 190. So 98.15 times 100 plus 63.5 times 900. And this is slightly less than the last one, 66,965. Next one, 98.15 times 60 plus 63.5 times 200. And I get a cost of 18,589. So far, that is by far the least. Last one, I'm multiplying each by 50. So I'm going to go up here and change a times 50 plus 63.5 times 50. And I get a cost of $8,082.50. So I'm looking for my minimum, which in this case is this last one. That is the smallest amount. So minimum cost of $8,082.50 at the point 50, 50. That's how you would state it on your homework. All right, moving on. We're going to do two problems. I have questions later. Oh, thank you. We're going to move on to number 5. And so this problem is going to walk us all the way through how to write your constraints, how to write your profit equation, how to graph it, and we are going to utilize Desmos. So for, let's read through here. First, I'm going to look at the last part. X is for circuit 1, Y is for circuit 2. So it says their profits are $400 for circuit 1 and $300 for circuit 2. So I'm just going to replace what they told me. They told me to do X for circuit 1 and Y for circuit 2. So my profit is 400 per X plus 300 per Y. That's what that first sentence states. Then it talks about our constraints. And so that's like the number of hours required in this case. So the process involves both types of circuits to be manufactured on machine A and machine B. So let's look at this first constraint. So I'm looking at machine A. And I'm going to go ahead and highlight that because it helped me organize. So 2 hours on machine A for circuit 1 and 1 hour on machine A for circuit B. So I need 2 for machine A, and this is for circuit 1. Remember, circuit 1 is X, plus 1 hour on machine A for circuit 2. Remember, that's Y. This is X, so plus 1Y. And it says that they can only allocate 100 hours per day on machine A. So it has to be less than or equal to 100. So again, this is all about hours. Okay, now machine B. So there's 1.5 hours on machine B and 1.5 hours on machine B for circuit 2. So this equation looks much simpler. 1.5 hours is required for X, plus 1.5 hours is required for Y. And I should have put, I should have highlighted this in yellow too because it went with the last one. Machine B is in orange, and I can allocate no more than 90 hours. So this should say less than or equal to 90. Graph the constraints. So we're going to use Desmos, and I'm going to go ahead and set this up. And I am going to go ahead and guide us. This is 100, 80, 60, 40, 20, 10, which would mean this is 0. And I did this by looking at Desmos first. Again, remember this is Y. Here is X. So 10. Sorry, I changed. I did this wrong. Sorry. $20, $40, $60, $80, $100. This should be $60. Okay, so when you go to graph, you're only going to graph the constraints, not the profit. So I'm going to grab Desmos. We're only inputting these two. So the first, I have 2x plus 1y is less than or equal to 100. Now I'm going to hit this little wrench tool at the top, and I'm going to change, I don't need 0, I'm going to change my x-axis to be 100, and y, I'm going to do the same. Y to go from 0 to 100. Okay, so now I'm going to enter my next equation, my next constraint, right, is 1.5, whoops, 1.5x plus 1.5y has to be less than or equal to 90. Then I'm going to kind of zoom out. Okay, and you can see our graph. So I'm going to start with the first one. The first one crosses at 150. So here is my graph. The first one crosses at 150. And less than or equal to would mean that I shade below the line. All right, the next one, I did these in opposite colors. I'm sorry about that. It crosses at 60 and 60. And is also shaded below. So here is my graph. I'm going to look for the vertices of my feasible region. So I have one here, here, and here. You're looking for where I have both red and blue shading. So I'm not using the vertices up here because this is only blue. Only the blue equation is here. And over here is only red. So you're looking for where the two colors overlap. I guess this also would be a vertices, but it's 0, 0. Now using your phone or Desmos, you can identify the vertices by clicking on that dot. So this tells me that this point here is 0, 60. This point here, if I click on it, is 40, 20. So that is here. This is here. And this point here is 50, 0. Sorry. So I'm going to use those points, and I'm going to record them here. So my coordinates were at 0, 60, 40, 20, and 50, 0. So I'm going to enter these. It says maximize their profit. So it's just doing everything we did earlier but by hand. So I'm going to plug these points into my profit equation. And I'm looking for my maximum. So I'm going to start with 0 and 60 and use my calculator. So 400 times 0 plus 300 times my y value of 60. This first point gives me a profit of 18,000. The next point is 40, 20. So 400 times 20 plus 300 times, whoops, this should be 40. Plus 300 times 20. And this gives me a profit of 22,000. The last point I'm plugging in is 50, 0. So the reason I'm not bothering with the point 0, 0 is that would just give me a profit of 0. But I am going to plug in this one. So 400 times 50 plus 300 times 0, and I get a profit of 20,000. So which one gave me maximum profit? This one here. So I have a max profit of $22,000. Now I know X is circuit 1, and I know Y is circuit 2. So based on this coordinate, I would need to make 40 circuit 1s and 20 of circuit 2. And that is how you will do the homework for this section. And you are going to have to do it out of the book. And I will supply you with those numbers. Thank you.